Okay, greetings. In this problem, we want to calculate the molar mass of adrenaline when we know that placing 0.64 grams of adrenaline into 36 grams of carbon tetrachloride elevates the boiling point by 0.49 degrees. And we know that the boiling point constant for carbon tetrachloride is 5.02 degrees Celsius per mol. So first we need the boiling point elevation equation, and I'm going to write it as delta T equals I. I is the Van Hoff factor, which accounts for electrolytes breaking up into ions. So if you had like sodium chloride, which breaks into 2, this is a 2. Adrenaline is a non-electrolyte, so I is 1, and it's usually omitted from the equation. But I want to include it here to make sure that you use it when you do have an electrolyte, times the Kb times the molality. Okay, and I'm going to use 3 loops for molality. Molality is the moles solute, and we're going to use N for moles, per kilogram solvent. And we're writing the mass as kilogram because it must be in the units of kilogram. And Kb, let's take a quick look at that. Kb is equal to 5.02 degrees C divided by the molality, okay? And the molality could also be expressed as moles solute per kilogram solvent, okay? All right. Now, let's, we want the formula weight. We don't have an equation with the formula weight, so we have to come up with an equation with the formula weight. So what is the formula weight? The formula weight is equal to the grams per mole. So since I've got an M, and I usually write my mass as this, but I'm using this for molality, I'm going to write it as M with just one loop, okay? And I'm just going to write here in parentheses grams, so we realize that that's for mass. The grams per mole, which of course is in the units of, has the units of moles, okay? All right. Now, let's look at this here. What I'm going to do is substitute in for molality. So I have delta T is equal to, and I'm going to, since this is a non-electrolyte, this is 1, and as I said, many books even ignore the 1 when they're writing the Van Hoff factor. But I think you should write it down there so that if you do have an electrolyte, you remember it. And this is equal to Kb times the moles of solute per kilogram of solvent. Now, here I have the moles of solute. I want the formula weight, so I'm going to rearrange this equation and write it in terms of the moles solute equals the mass of the solute. Whoops, I keep writing that as an M because that's where I normally write it. Solute per the formula weight of the solute, okay? Now I can substitute this, which is N, into here, and I get Kb from here, and I'm just going to write over kilogram solvent times the mole solute, which is the mass of the solute per the formula weight of the solute, okay? And that's all equal to delta T. So I want to solve, I'll just write over here equals delta T. I want to solve for this, so I multiply both sides by the formula weight, divide by the delta T, and I get the formula weight of the solute is equal to, now I've divided by delta T, so in the numerator I've got Kb times the mass of the solute. I'm just going to put the units there in parentheses gram because I usually use this symbol for mass, and I'm using this one, and sometimes I get confused by that. Okay, and now I've brought the formula weight over there, so I have left the kilograms solvent, and I'm bringing the delta T down, so I have delta T. Now I'm going to bring this out. Now Kb is 5.02 degrees Celsius per mol. I'm going to write it in this term so we can follow the units, okay? So Kb is 5.02 degrees Celsius reciprocal mol, okay? And the reciprocal mol would have the moles solute in the denominator and the kilogram solvent in the numerator, okay? Now I have my mass of the solute, okay, which was 0.64 grams of adrenaline, okay, and now I divide by the mass of the solvent, the carbon tetrachloride, but it must be in the units of kilograms, so it's 0.036 kilograms of the solvent, and I multiply by the delta T, which was 0.49 degrees C, okay? Now we can look at our units, okay? The degree C cancels the degree C, and the reason I wrote this in units of molality was so that things could cancel. So I have my kilogram solvent over kilogram solvent, and what I have is my grams adrenaline, which is the solute, divided by moles adrenaline, which is the proper unit for formula weight. So I get out my calculator, and this comes up with 182 grams per mole. And there is your formula weight for adrenaline, okay? The take-home messages are, write out your equations. I include the I. If it's a non-electrolyte, just knock it off as 1. Solve algebraically, substitute in, and then at the last step, do your algebra. Okay? Do your arithmetic, okay? So solve it algebraically, then put in your numbers, then use your calculator. All right, good luck.